Hey there, I'm Max Primo, and welcome to this walkthrough on setting up a multiplayer lobby system in Unity. I'm currently pursuing my undergraduate degree in computer science, and I aim to assist fellow developers in crafting their own games by sharing my experiences. If you have any questions, don't hesitate to reach out through a comment or an email on my channel page. Before diving into the details, it's important to note that this walkthrough assumes that you have a solid grasp of Unity and C#. While multiplayer games offer fantastic experiences, they can be quite intricate, so please keep that in mind. Now let's get started. Quickly, I wanted to highlight the structure of the lobby system. Our goal today is to create a functional lobby system that handles callbacks, loading, and spawning of our players. This lobby system should also include a way to join other players. In this project, I've structured the code into several components. First off, we have the lobby handler script, responsible for managing connections to our rooms. Once a player joins a room, they're assigned to a player identity script. This script handles all the persistent data specific to each player. The player identity script communicates with our game manager script. The game manager takes care of queuing up players and spawning player managers. Player managers represent the physical players of the game. They handle movement, animations, and character actions. While it's possible to combine player identity and player manager into one object, separating them is a good practice. This separation makes tasks like respawning and adding new features much easier. For this walkthrough today, we'll be using the Photon Pun 2 framework. You can find the download link below. Setting up our project for Photon is fairly simple. Just download Pun 2 from the asset store into your project and head over to photonengine.com. Then, create an account and head over to the dashboard. Press the Create New App button and specify that this app is using the Pun SDK. Create it and copy the app ID. This is important for establishing the connection between Photon and your Unity project. Paste this app ID into the Pun setup wizard that is prompted after downloading Pun. Visit the documentation or leave a comment if you have any more questions. Heading to the lobby scene, start by creating a new canvas and naming it Lobby Canvas. Adjust the Canvas Scaler component's UI scale mode to scale with screen size. Jeez. And set it to the appropriate reference resolution. Also, create two new scripts, Lobby Handler CS and MenuManager.cs, and attach them. Next, create three separate panels named Main Menu, Room Menu, and Connecting Menu respectively. For the Main Menu panel, add two buttons named Join Room Button and Create Room Button, along with an input field named Room Code Input Field for later use. In the Room Menu panel, add an image and apply a vertical layout group component, ensuring to uncheck the Child Force Expand width and height options. Name this object Player List. Within the player list, add a new text object to display the players' names. Drag this text object into your prefabs folder and remove it from the hierarchy. Additionally, create a new text object named Room Code Text to display the room code, and include two buttons, a Start Game button and a Leave Game button. For the Connecting Menu panel, simply include a text element to inform the players that they are currently connecting to the lobby. Alright, now that our scenes are set up, let's take a closer look at the scripts. Beginning with the Menu Manager, attached to the Lobby Canvas game object, this script is relatively straightforward. It consists of a list of game objects named menus and a single public function called OpenMenu. This function accepts an index as input and activates the menu corresponding to that index while disabling all the other menus to clean up. Back in Unity, don't forget to assign our three menus to this list in the inspector. Let's take a closer look at the Lobby Handler, which serves as the core of our networking code. This lobby handler is responsible for managing connections to and joining rooms. make sure you are inheriting from mono behavior pun callbacks, and import TextMesh Pro and Photon.pun. Starting with the variables, we have a public reference to the menu manager, allowing us to control the menus. Additionally, we define two constant integers, one for the default room size and another for the game scene index. Feel free to adjust these values according to your game's requirements. We also have a private string to store the current room code. Moving on to the UI elements, we store references to several components. Here, I am utilizing TextMesh Pro, but Unity's built-in UI will work just fine. We store a reference to the room code input field created earlier. Also, we keep references to the Start Game button, room code text, the player list item prefab, created previously, and a reference to the transform vertical layout group player list. These elements play a crucial role in managing the lobby interface and room connections. Now let's delve into this script's functions. I've organized them into different regions. We have regions for Unity functions, which contain start and update for general game logic. Next, we have callbacks from Photon for handling events from the Photon framework, and input functions for responding to user interface interactions. In our Unity functions, we have the start function. Here, we utilize the menu manager's open menu method to open the connecting menu. Following that, we attempt to connect to the Photon server if not already connected. This connection attempt triggers a callback named onConnectedToMaster. Upon successfully connecting to the Photon server, we invoke the onConnectedToMaster callback. Within this callback, we open the main menu and set the player's username. For demonstration purposes, I've simply set the username to a random number, but you can easily integrate this with an input field for player input. Next, we proceed to the join lobby callback and set automatically sync scene to true. This setting allows the master client, which is the owner of the room, to control scene changes for all the clients in the lobby. This ensures synchronized scenes across all connected players. Before continuing further, let's create the function to update the room player list. Let's name it onUpdateRoomList. First, we'll gather all the players in the room by accessing Photon Network.playerList. This is a stored list provided by Photon of all the players in the room. Next, we'll clear the current children under the layout group responsible for displaying the player list. Finally, we'll repopulate the list with the current players retrieved from Photon Network.playerList. This ensures that our player list always stays up to date with the current occupants of the room. Let's continue by handling more of the callbacks. We'll start by writing a public override void onJoinRoom method. This method is called by Photon when a client successfully loaded into a room. Within this method, we'll use the menu manager to open the room panel, providing players with access to room-specific functionalities. Additionally, we'll update the current room code text to display the current room's join code, which we will set in the room creation process later on. Moving on, we have the onLeftRoom method, which is called when the local player leaves the current room they were occupying. In this case, we'll simply open the main menu again. For the onPlayerEnteredRoom and the onPlayerLeftRoom callbacks, we'll focus on updating the room list, as these callbacks are triggered for the other players in the current room. Additionally, we'll handle the scenario where the previous host leaves the room, which triggers Photon to migrate the host to a new host. This involves changing the behavior of the Start Game button, ensuring that it's activated for the new host. Remember that the Start Game button is only activated for the host player, so we need to update its status accordingly. Finally, for our lobby handler script, let's focus on the input functions that will be triggered by the UI in our scene. We'll start with the functions for joining and creating rooms. Firstly, let's create a new function called tryJoinRoom. Within this function, we'll use a try catch to attempt to join the room by invoking Photon Network.joinRoom and passing the text from the room code input field as our room code. This approach allows us to handle any errors that may occur while joining a room. Next, let's create another function called tryCreateRoom. Before doing anything, let's set up the code generator to generate our room codes. You can use your own code generator, but I've provided one in the description below. It's a fairly small script that includes a generate random code function that generates a random 6-digit code. This function is static, so you can call it anywhere. In our try_create_room function, we'll reference the Photon Room Options class to create new options for the room we're about to create. The Room Options class has common room properties needed during room creation, such as max players and other room options. Also, make sure to check out the Photon documentation to understand the different room options you can configure. Finally, within the try_create_room function, we'll generate our code using the provided code generator and then create the room. Make sure to set the room's name as the generated code and pass in the room options as well. For our in-room functions, we have start game and leave room. Leave room just calls the Photon's leave room function, and the start game runs only on the master client and uses the Photon Network's .load level to change the scene. This is similar to Unity's built-in load scene function, but it makes sure to sync the level loading with all the clients. Great! Now we have a working lobby handler for our game. Don't forget to hook up the variables and the UI elements back in Unity. First, we will assign our objects to the proper places. Next, to configure our buttons, head under the main menu panel and add a new on-click event for both the join and create room buttons. Drag our lobby handler to the events and make sure to call their corresponding try, join, and create room functions. Make sure to do the same under the room menu panel with the start and leave game buttons. Now we need a way to represent our player. Earlier I discussed about splitting these up into the identity and the physical player. Create two separate game objects named Player Identity and Player Manager. Now, create two scripts, Player Identity and Player Manager, and assign them to their corresponding object. Also, add a Photon View component to each of these. Next, create a Resources folder and make sure it's spelled correctly, and drag both of these objects inside and create them as prefabs. For organization, I created a new folder inside named Photon Prefabs, but this is not necessary. Just remember your organization for when we instantiate the prefabs. In the Player Manager script, for this example it's pretty simple. Cache the attached Photon View on start and create a reference for this physical player's identity. We will save this locally for reference. Now, addressing the Player Identity script, add references to the Photon View, Player Manager prefab, the current Player Manager, and a bool to flag if we've loaded or not. This script will handle telling the game that the player is loaded into the scene through a ready system and creating the physical player. Starting with the ready system, subscribe and unsubscribe to the on-scene loaded event and on-enable and disable. Make sure to also cache the Photon View attached to this game object. In on-scene loaded, return if we aren't the local player. If we are, use the cached Photon View to call an RPC to confirm our ready. Make sure that the target of the RPC is the master client and pass through a true boolean. As a quick side note, make sure to familiarize yourself with the different types of remote procedure calls. For Photon, this is the recommended format. Finally, spawning our physical player, create an RPC function named RPC spawn client and a private void to create the controller. In our RPC function, make sure that we've received the call locally and create the controller. Here, we will cache the current player and instantiate using the Photon Network. We will call the RPC spawn client later. Now we need a way to spawn our player identities. A simple but effective way I've found is by using a singleton called Room Manager. Go ahead and create the empty game object in Room Manager script. Don't forget to attach it. Starting off, create the Room Manager as a singleton. Make a static instance of the Room Manager inside a wake, and destroy if there's already been an instance of this, and make sure to call don't destroy on load so this object is persistent throughout all scenes. I also have a constant integer, which is the build index of our game scene, and a local reference to that player's current identity. In on enable and disable subscribe and unsubscribe for the on-scene loaded event. This will tell us when to spawn our player identity. If we've loaded into the game scene, utilize Photon Networking to spawn our player identity across all the clients. Note, here we are storing the player identity locally for any time we may need to reference it. Also, for Photon Network.instantiate, it takes a string path name, where it automatically searches in the resources folder that you created earlier. For our last script of the video, let's discuss the Game Manager. It's a manager script that remains in the game scene and handles current game-related functions for us. At the moment, it handles spawning the players by receiving the call on a master client, then putting that call into a queue and going one by one emptying that queue by spawning the players. Here, we'll be calling RPC spawn client that we created back in the player identity script. First, head into the game scene and create an empty game object. Then, create and add the Game Manager script to it and open it. You're probably used to this by now. Make sure you have all the same using statements as I do here, and then set up a singleton structure for our Game Manager, excluding the don't destroy on load, as we don't want the Game Manager to persist between scenes. For our attributes, we have a list of spawn points that the Game Manager will loop through to spawn the players. Next, I have my spawn queue variables. First, a queue of photon views named spawn queue. Then, I have some variables to control the queue. Wait before spawn time, current spawn point index, and a bool to flag whether we are currently emptying the queue. Also, it's good practice to store a list of player identities for whenever you need it to access it during your game. Lastly, for the variables, I have retries and max retries. These integers are put in place to mandate how many times we will try after a failed task in the manager. This is essential in multiplayer games because they don't always result the same way. There are a multitude of factors like latency that could impact the functionality. Now, onto the functions. In the start function, we set retries to 0 and call collect players. Create that public void named collect players now. Back in the player identity script, we made a ready flag to be set to true whenever the players finish loading into the game. Here, we will retry the collection if one or more of the player identities aren't ready, as we don't want to start the game if some players haven't loaded in yet. If they have loaded in, call start game. Just for the functionality of this tutorial, start game only calls spawn players, so make two private functions named start game and spawn players. Call spawn players on start game. Now, for spawn players, we ensure that this is only being called on the master client, as we only want the master to dictate when spawns happen. Now, we loop through the players that we collected calling update queue function, passing through each of the player identities' photon views. Create that function now. In update queue, make sure it takes a photon view parameter, and it is only called on the master client. Here, we enqueue the photon view into the spawn queue, and if we aren't emptying the queue already, start the coroutine to empty the queue. The meat of our player spawning lies in the handle spawn queue. Make sure it's a coroutine of IEnumerator, and at the start, set emptying queue to true. If the spawn queue isn't empty, we will peek at the top of the queue to its head. Call a buffer to wait a few seconds before spawning, and then call the RPC through the player identity through the head of the queue's photon view. In the RPC, pass through the current spawn point's position by using the index. Move the spawn point index either forward or back to 0 if it has exceeded the amount of spawn points. And at the end, dequeue from the queue as we have just handled it. Start the coroutine recursively in case there are more than one photon views in the queue. At the end, set the flag to emptying to false. Lastly, we have one callback to handle which is on disconnected. This is whenever you, the local player, gets disconnected. Make sure it's an override void, and here, we want to ensure that the manager is deleted as we will pick up a new one in the lobby scene. Then, load back to our lobby scene. That's it. Just ensure that you create and add spawn points to the game manager's list in the inspector, and that's your lobby system completed. Here, we can test the lobby scene working by building the game, connecting the two instances to the same lobby and starting the game. Now, we can see that the player identity is loaded in first, and the player manager is spawned in afterwards. I would be more than happy to expand upon this simple system as there's still so much to cover, so please leave a comment down below with suggestions of what you would like to see next. And as we reach the end of this walkthrough, I would like to express my gratitude to you all for joining me on this journey. If you need any assistance, please leave a comment below. Until next time, happy coding.